Good day, students. How are you doing? Welcome to class. I'll be taking you through the subtopic acceleration. That is how to understand acceleration. An object accelerates if its speed increases. Acceleration is the change in speed per unit time. An object that slows down in motion is said to decelerate or undergo negative acceleration. Is acceleration associated with speed, velocity, and time? You know that speed is the distance traveled by unit time, and velocity is the displacement by unit time. So acceleration is a function of both speed, velocity, and time. Let's check if it's true. Check. Now, let's move to speed time graph. Earlier on, the motion of a moving object was represented by a distance time graph. It can also be represented with a speed time graph. A speed time graph shows how the object's speed changes as it moves. The diagram below shows the speed time graph of a bus on a busy route. At first, it has to stop frequently at bus stops. Towards the end of its journey, it maintains a steady speed, that is a constant speed. The slope of the speed time graph indicates the bus acceleration. The steeper the slope, as you can see, the greater the acceleration. A negative slope means a deceleration, slowing down. A horizontal graph means a constant speed. So which one of the following could not be a unit of acceleration? From what we've learned so far, we've been able to say that what acceleration is what velocity per unit time. So what is the unit of velocity? The unit of velocity is meter per second, and the unit for time is seconds. That means we now have the unit of acceleration of meter per second square, or it can be referred to as kilometer per hour squared, or better still, miles per hour per hour. So from the options, we have kilometer per squared seconds. Yes, if hour is not used, we can use second. That will be kilometer per second squared. Miles per hour per second, yes. Meter per second squared, yes. Kilometer per second is the unit of speed or velocity. So it's not a unit of acceleration. Let's check. So a car sets off from traffic light. It reaches a speed of 27 meters per second in 18 seconds. What is the acceleration? So with this, acceleration as we have it is equal to velocity over time. Velocity is 27 meters per second, and the time is 18 seconds. So here we have 3, if divided by 9, and here we have 2. That gives us 1.5 meters per second squared. Do we have it? Yes. All right, let's move on. A train initially moving at 12 meters per second speeds up to 36 meters per second in 120 seconds. What is its acceleration? That is the acceleration of the train. Looking at this, it slightly differs from the conventional way we've known acceleration to be. Now we have initial speed here, or initial velocity. Let's call that u, and that will give us 12 meters per second, while the final velocity is 36 meters per second, and the time is 120 seconds. Therefore, acceleration will now be v minus u over t. Acceleration plus 36 minus 12, all in meter per second, divided by 120 seconds. And acceleration will now be 24 over 120 meter per second squared. And that gives us 1 of 5. And that is 0.2 meter per second squared. Do we have it as our option? All right, let's check. Correct. Now let's move on. Distance moved during acceleration. A speed time graph represents an object's movement. It indicates when the speed changes. A graph can be used to deduce how objects move. This is done using the equation that is distance is equal to area under speed time graph. We are to note that the area under any straight line graph can be broken down into rectangles and triangles. Then the area can be calculated using the area of a rectangle is width, which is also known as breadth, times height. Area of a triangle is half of the base times the height. This is illustrated in the activity below. From this activity, a man sets off down a steep sky slope. His initial speed is 0 meter per second. After 10 seconds, he is traveling at 30 meters per second. We have to calculate the distance it travels in this time. Now, looking at this diagram, we have a triangle. And what is the area of a triangle? The area of a triangle is half base times height. We will now use this formula, area of a triangle, to calculate the distance. That is half base times the height. So we have half times the base now represent 10 seconds times the height represent 30 meters per second. So we now have the area under the graph to be 150 meters per second. So let's see the distance. That's correct. So let's go for speed and velocity, vectors and scalar. Velocity is an object speed in a particular stated direction. Velocity is a vector quantity. This shows that velocity has magnitude or size and a specified direction. Example is the movement of an aircraft at 600 meters per second due north. Another example of vector quantity is weight of an object. However, speed is a scalar quantity with magnitude only. Other examples of scalar quantity is temperature. Let's use this exercise in terms of drag and drop to differentiate between vectors and scalars. Can lift be a vector or a scalar? Lift, let's see. How about the displacement? Does it have a specific direction? Let's see. How about drag? For instance, if a plane is moving in the air, let's also see. How about work? Work is a scalar quantity. Can that be true? Let's also see. How about speed? That's distance traveled per unit time. Distance is only has magnitude. Let's also see momentum, mass times velocity. Velocity is a scale vector quantity. Let's see. How about weight, which is in relation with force? That's a vector quantity. How about density, mass per unit volume? Mass is a scalar, volume also is a scalar. So time also is a scalar quantity. It only has magnitude, no direction. So we can check. That is it. So let's treat these past questions and see how far we can move. The speed time graph shows the motion of a car. Which route describes the motion? Let's take the options one after the other. So between P and Q, we have acceleration. Between Q and R, moving at constant speed. Can that be? Between P and Q, moving at constant speed. No, that's acceleration. Between Q and R, decelerating. Nope. Between P and Q, moving at constant speed. Can that be? No, it's accelerating. Between Q and R, not moving. It's moving at constant speed. Between P and Q, it's accelerating. Between Q and R, not moving. It's moving at constant speed. So let's see. Between P and Q, accelerating. Between Q and R, is moving at constant speed. So we check. That's correct. Now, looking at the second question, the diagram shows the speed time graph for a car. Which area represents the distance traveled while the car is accelerating? While the car is accelerating, it's moving from 0 and covering a triangle before going for constant speed at y. That will be x. Let's check. Correct. Let's move on. So in summary, we are to choose the correct statement. An object accelerates if its speed decreases. Can that be true? No, that object is undergoing deceleration. An object decelerates if its speed increases. No. An object accelerates if its speed increases. Yes. So let's also see this. Velocity and speed are both scalar quantities. No, velocity is a vector quantity, speed is a scalar quantity. That statement is not true. The speed is a vector quantity, while velocity is a scalar quantity. No, velocity is a vector quantity, speed is a scalar quantity. Now, looking at the third one, velocity is a vector quantity, while speed is a scalar quantity. Is correct. Yeah. Thank you so much for your time. You can do well to subscribe to our website www.edubbey.com for more of interactive notes and also classes online. Thank you for your time and thank you for watching. Bye.